It's time for another episode of the Future Ready podcast from Siemens. I'm Nick Finberg, your moderator for conversations on all things software-defined. We're continuing our discussion with Rainer Brehm, CTO and COO of the automation business at Siemens Digital Industries, on the role of software-defined everything in the evolving future of industry. In the last episode, we talked about how AI technologies can be leveraged on top of the foundation of software-defined automation, and it sounded super interesting with customizations for the operators on the shop floor. How fast is that transformation happening, Rainer?
The technology is there. I mean, number one. So it's not a topic around technology. I think it's a topic of how you bring it down and bring it into the shop floor, because still maybe some compute is too high and you need to have a lot of storage. That's a topic where we are working on. For example, when we talk about AI, bringing not large language model, but smaller language model, more specialized language models down to the shop floor, number one. Number two, in order to do it, to create this magic, you need to train them, you need to access the data of the specific machine, of the specific site, of the specific production. So you need to have the working manuals, you need to have the log book, how this machine will operate it. You need to feed this data into the system that it can, leverage that data. And we see that this integration work, you need to invest money in doing that. So, but if you can do that smarter and smarter, then this initial investment also is easier, and we're working also on that. And I think if we can do that, I think there will be a great adaptation if we can automate that integration. But we have a lot of customers which already see a great value in using it. I had a customer which even an executive person was looking at that, because also for that company it was very new, and we deployed it with a pilot customer, that kind of co-pilot for operations, and that executive came from an Arabic country, and the interesting thing was, you could communicate them with the system, and kind of, you don't need to type something, you can talk with the system. And the interesting thing is that person could even talk with the system in Arabic and got responses in Arabic, even so there was no training on Arabic languages. And if you see now, whether it's you have something, you do it in English, but you maybe somebody with Portuguese skills or Spanish skills comes over, you could interact even in different languages, and system takes care about it. So that's also something to make it more accessible, because you can interact maybe with your mother tongue with a machine if you're not capable of having maybe some specific terms in English or whatever is the machine was designed in.
That's really interesting. Yeah, because there's some language that's just very hard to think about, especially with technical information. Like, there are some cognates and things that are just transient across all languages, but there's some things that are just very hard to conceptualize in another language. If you're an expert with something other than English, like you learned physics or something in Portuguese, for instance, it can be very hard to translate.
And the other topic is, I think we have a lot of global customers which say, hey, I designed something, but I need to deploy the machines. I have factories all over the world, and I need to go into standardization. And currently what they're doing, they are translating all the things into all different languages and really program it, hard code it in the future. And then probably, again, one language is missing because the operator just came from whatever country. And I think that it gives much more flexibility.
So you talked about that a little bit, the distinction between doing this all at once for maybe a startup or a new business. How does that change between like a greenfield or a brownfield situation? What's the distinction between those two?
Well, in a greenfield situation, I mean, you can do a lot of things already from the first start. And we see a lot of customers, when we talk about reshoring manufacturing, that those customers say, if I now rebuild a factory which maybe I was producing only in one location in Asia, and I want to kind of reshore it to the US, to Europe, whatever. They want to build a state-of-the-art factory, and that's already going very much into digitalization. On the one side. On the other side, the biggest market is always brownfield, because there are existing factories which you are upgrading, which you are updating. and you don't rip out something because you want to be fancy, because you need to have a business case. So at the first topic, this is what I said also, getting first data connectivity is the first thing to be done, especially in brownfields. And then if you have this kind of a data blanket, then you can start adding features on there and save and solving pain points, as I discussed, or use cases.
Okay. So we've definitely been talking about like single site or even multi-site, but it's very much a fixed location. How does this change for something that might be moving around or a little bit more dynamic?
Yeah, absolutely. I mean, we have those customers as well. And one nice reference is they are producing thousands of containers, and they put it somewhere remotely, but they want to control those containers centrally. And they even might offer that as a service. And they have different ways, and they need to have a mass deployment. Like today, you do a software development, you change something and deploy it instantly on all different units. And that means you need to have a different way how you manage devices. So you need to manage devices not on site, because it might be a container in a very remote area. So you need to have a very good way of how you centrally manage devices, and or kind of the container. At the end, the container consists of a controller that need to be centrally managed and updated. And we need to have that kind of flexible deployment mechanism. And you need to do changes as quick, because maybe the clay is changing, or the surrounding conditions are changing. So you need to be very flexible acting. And we see that, or we have another customer which is a similar topic. It was around COVID, but it also now comes that a lot of micro factories going to be built. We have customers do micro factories to produce pizzas. We have customers doing micro factories to produce individualized medicine. So basically, you have container where you flexibly put them somewhere in the world where it's needed, or to treat water, for example. Another good example, maybe in crisis, or you have a flood and you need to put something there. And there, software-defined automation helps a lot, because you're centrally managing it, you're easily deploying it, and that's also another use case where we don't have a fixed factory which is built and run for 20, 30 years.
Yeah, you're thinking with variables rather than hard coding everything, so you can make it deployed very, very quickly for any number of situations that you're kind of thinking about.
Exactly. Yeah.
What role does AI play in this case? We've talked about it a little bit. We've talked about the customization. We've talked about data acquisition and manipulation for optimization. But is there something else that you're kind of looking at?
I mean, first of all, I told already on AI at the beginning. If you can go from a rule-based automation to a goal-based automation, that would be a dream. Yeah, you tell the system what need to be done, what is a goal, what I want to be done, and the system figures out itself how it's going to be done. Yeah, and that is AI. And here we talk about topics like physical AI, where you might have vision action models which are running close to the controller or on the controller, and doing that task which was not thought before, which is you automate the unknown. That's one element. I see we can be much better in optimizing and automating workflows. And I give you an example today. Like when you do an engineering, you engineer your machine, and using our CAD tools and Team Center doing machine automation. Then you start simulating, and you do a behavior simulation, and you do a sizing. What size of motors you need to put in order to do the task, what mechanics you have, and so on. So you do this. And then if you have that, then you select maybe your automation equipment and say, okay, for doing this, I need this kind of motor, this inverter. I want to show this on my panels. I need to have this switches, this type of security, and so on and so on. And then if you have done this, then you say, now I need to put it in a cabinet. So you're starting doing electrical engineering, electrical design, you build your cabinet. And then you start having a cabinet, you go into automation again, and you do your hardware configuration in the automation environment, and then you're writing a program, and then you are testing and validating your program. You do it in a virtual world with maybe a virtual PLC, and then you deploy it and you test it and so on. And then you want to further optimizing it. So there is a complete chain of maybe even different engineers doing different tasks in order to get something done.
It sounds like it's a dance between like the hardware-defined and the software-defined worlds just kind of merging together a little bit.
Yeah, and then we always have the topic, does it need to be done in a sequence, or you can do concurrent parallel engineering? Then you just have the handover, from the mechanical to the electrical to the automation engineers, and then maybe something is going wrong there. And I could imagine that in the future, those workflows are automated. So we don't only talk about automation from an execution perspective, but also from an engineering perspective. And we're working here, for example, with other companies, because again, we need to talk about the ecosystem. It's not only Siemens, a lot of companies out there, and also competitors of Siemens, which we need to somehow bring together, because if our customers want to be more effective, they need to automate workflows. And here, the logic around agents come into play. So there will be agents which do this works, do this orchestration of all these different tasks. And for that, we also need to bring then AI into our tools and make them accessible for agents. So we need to enhance our tools that agents can say, I have now this bill of material, and now I build a cabinet. And maybe then we go to a company, one world market leader is ePlan, and ePlan says, okay, I take the data automatically from an agent and build maybe with a copilot automatically this cabinet, and then give the data back and do the automation engineering with it. So we need to have that also in our mind, how AI play a role. So that kind of agent-based workflow optimization will be a topic. And then if you are now on the shop floor, agents going to be executing things. And this is, we will talk about physical AI, where you have then different machines which have different skills, or maybe have a variety of skills, which maybe you can even update on the fly. And then there are agents to get something done, to execute on a bill of process. They will automatically, connect different machines, different skills to get something done. So you can extend that logic of workflow optimization of agents then to the physical world.
Okay, that is the perfect way to circle back to the start of our discussion on copilots. And it makes a lot of sense, since we are always talking about interconnecting development and operations. I have so many more questions for you, Rainer, but I think we should wait for our last episode. Thanks for listening, and make sure to subscribe so you don't miss the last part of our discussion with Rainer Brehm. Until then, check out the description for more ways to learn about software-defined everything.